Good afternoon everyone. Myself Mr. Ahmed Hussaini, working as assistant professor in Sharad Institute of Technology, College of Engineering, Yadra in Mechanical Engineering Department. Today we will discuss the first module, and let's start with the unit number 5, some introductory part of the source of energy for power plant and types of the power plants. There are so many power plants like steam power plant, hydroelectrical power plant, nuclear power plant, geothermal power plant, wind power plant, hydroelectrical power plants are there. Now in this particular video we will discuss about the steam power plant. The course outcome of that particular unit is outline the different power plant for power generation and explain their working with the neat sketch. Now the first point of the unit is the fossil fuel. The fossil fuel are in the form of coal and natural gas. They are generally used to produce an electricity. The ultimate aim of that fossil fuel power plant is to convert that thermal energy into mechanical energy, and at the end, ultimately the success of that mechanical energy is to convert that electrical energy as well. In case of that electricity generation from the fossil fuel, the best example is that steam power plant. The steam power plant, in that particular situation, electricity generation from the fossil fuel, the generally primarily used, there are two types. The first is the turbine which is operated by the steam, and the second is turbine which is operated by the gas. Here we will discuss about the first, the electricity generation from the fossil fuel with the help of the steam. So basically that steam power plant works on one thermal cycle. The name of that particular cycle is the Rankine cycle. There are two vapor power cycles are in picture. The first one is that Carnot cycle, second one is the Rankine cycle. This particular diagram will help you to study the working of the fossil fuel power steam turbine electricity generation power plant. So here we will discuss the working of that steam power plant first. Basically there are four important components of the steam power plant. The first is a steam boiler, second one is steam turbine, the third one is a steam condenser, and fourth one is pump. The main function and the types of the boiler is, the main function of the boiler is to produce high pressurized steam by converting water into steam by adding the heat in it. And the fuel required for working of that steam boiler is generally coal in case of the large capacity power plant, and sometimes for low capacity power plant or for that sugar factory, generally we will use the bagasse as a fuel in the boiler. There are two types of the boilers are available. The first is fire tube boiler, second one is water tube boiler. But for high pressure capacity, high power generation capacity, we are using water tube boiler. The main function of the boiler is to produce or to convert the water into steam, and ultimate aim is to produce the high pressurized steam. The second important component of the steam power plant is a steam turbine. There are two types of the steam turbine. The first is works on the impulsive action, so it is called as impulse turbine, and second one is works on that reactive action, that is a reaction turbine. The third important component of the steam power plant is steam condenser. There are basically two types of the steam condenser. The first one is that jet condenser. Again, that jet condenser is classified into 2 to 3 types. The first is parallel flow jet condenser, second one is counter flow jet condenser, third one is ejector type jet condenser, fourth one is that regenerative type jet condenser, and second important types of the steam condenser is that surface condenser. There are 2 to 3 types again. The first is downflow surface condenser, second one is that shell and tube type surface condenser, third one is most important, that is center flow surface condenser is there. Again, that surface condenser is always conjugated with one extra component. That device, the name is cooling tower. The main function of that cooling tower is to supply the cool water in the passage of condenser shell. When the cooling water enters in the condenser shell, it acts as the heat exchanger. It will help to exchange the heat, and the main function of the steam condenser will achieve, that is for the conversion of the steam into water by rejecting latent heat in that particular cooling water passage. Now the fourth important component is pump. Generally jet pumps, centrifugal pumps are used. Again, that particular water is continuously fed to the steam boiler. As far as to be surface, that particular steam turbine or that power plant is to be concerned, again there are so many mountings and so many accessories are used. The basic accessories are generally superheater, economizer, air preheater are generally used. And as far as to be mounting, so many valves, water level indicators, safety devices are to be used. So let's start with the working of that steam power plant or electricity generation from the fossil fuel. Whatever the steam is, high pressurized steam is generated in the steam boiler is enters in the steam turbine. In steam turbine, it consists of the n number of the blades. Sometimes the compounding is there. Compounding is nothing but step-by-step arrangement of the blades and nozzles arrangement. So when the high pressurized steam is enters in the steam turbine, the expansion is carried out and the turbine blades get start rotating, and hence ultimate aim of that rotation is to produce the mechanical energy at the end of this particular shaft. Further, that particular shaft of the steam turbine is connected to the or synchronous with the generator to produce an electricity as far as the law of the Faraday. When the current carrying conductor is kept in a magnetic field, it will experience a force and voltage is generated and current is produced. After expansion process in the turbine, low pressurized steam, wet steam is there and it enters in the condenser area. Condenser is nothing but one kind of the shell, airtight shell. We have to maintain the 100% vacuum in it in order to produce and condensate. The main function of that steam condenser is to condense the steam, means to convert the steam into water by adding cooling water in the passage of that shell with the help of the cooling tower. There are so many types of the cooling towers are there. Natural type, forced type, draught types are used. Again, that condensate or water enters in the steam boiler with the help of the pump. So this is a basic general idea of our working, construction and working of the steam power plant. The tentative efficiency of the steam power plant is approximately in between 27 to 35%. Now there are so many auxiliary components or the parts of the steam power plants is there. The first one is the coal storage. Definitely coal is act as the fuel in case of that fossil fuel power plant, that is steam power plant. So it is a place where coal is stored which can be utilized when the required. Simultaneously we require coal handling. Generally lignite and pulverized coal are used in the boiler. It is in the form of some powder. So second one component we already discussed, that is boiler. Air preheater is there. Air preheater improve the performance or improve the combustion process. That's why that air preheater is required. It acts as the auxiliary device. It's supposed to be accessories in the steam power plant, or it is a part of the boiler. Economizer is used to feed the hot water to the boiler. Next component is turbine. Next is generator. Simultaneously ash storage is required. It is used to store the ash from the burning of the coal. Dust collector is there. It is collect the dust particle from the burnt gases before it released to the chimney. The next is condenser. We will already discuss it. Cooling tower, chimney is there to remove the unburnt or burnt gases through the particular area to the atmosphere after treating process. The feed water pump is also used. So this is all about that steam power plant. Steam power plant works on the Rankine cycle. There are four processes in case of that PV and TS diagram. The first is heat addition process. It occurs in the boiler. Second one is expansion process. It occurs in the particular area of the turbine. The third one is heat rejection. It occurs in the steam condenser. And fourth one is that warming operation it is happen in case of the pumping operation. So the second point of our discussion of that particular module is petroleum product. Petroleum products are material derived from the, definitely it is derived from the crude oil. It is a process in the oil refineries. Okay, so there are well-known petroleum products are like fuels. It includes gasoline, diesel, LPG, fuel oil, kerosene is there. Also wax are there, asphalt is there, tar is there, petrochemicals like plastics it is one of the part. In addition, also some kind of oil refineries, some come from the refining process are there. Some are in the form of liquid, also some are in the form of the gases like propane, sulfur, lubricant, different kinds of the industrial waxes. So these are the some byproduct of that petroleum. Thank you very much. This is one kind of the introductory video. It is related with the unit number 4, the types of the power plant. In this particular video, we will discuss the working of the steam power plant. Hope it will helpful in that particular situation. Thank you very much.